现在将录制本次会议。
Okay.
Okay, sorry.
Yeah, no, thanks for that. This would be useful actually for all of us to be recorded. So, as we all are, I think, keenly aware of the massive growth of AI, especially in cloud. And in the last few years, we've seen the growth. And of course, in the last, maybe a year or half a year, we've seen the growth even more. And GPU systems are central to delivering this AI experience, running these AI workloads, for these cloud companies, right, who are adopting GPU systems. And this, what this means is, the need is even greater for, quicker and faster and efficiently adopting these GPUs in the various cloud data centers. And if you look at it, it's two sides of the coin. There is the hyperscaler view of the problem and the GPU vendor or supplier view of the problem. From a hyperscaler point of view, hyperscalers would like to integrate, the latest sort of GPU offerings out there quickly, so it's time to market into their infrastructure. And in order to do it quickly and efficiently, really, they want to reduce sort of the engineering toil that goes into all these integration activities, right, between the GPU vendors' products and the hyperscaler environment. And there's a lot of common sort of non-differentiating, but very, very critical and important activities that happen that take up a lot of engineering time. So hyperscalers would definitely like to reduce it to meet the goal of this high quality, time to market GPU product offering in their data centers. And then if you look at the GPU supplier point of view, it is any sort of they deal with different hyperscalers, different hyperscaler requirements, and in many cases subtly different requirements that their ability to deliver quickly.
Did we lose Vijay or I already lost?
Yeah, looks like it's
Yes, I think sometimes he gets glitches.
Sujay, you're back. You cut off.
Oh, did I cut off?
Yeah. The last 30 seconds.
Oh, sorry. Okay. So I don't know if you heard the GPU supplier view, everybody. So yeah, so it is. Can you guys hear me? I just want to make sure.
Yes, now we can.
Yeah, you can.
Okay, sorry about that. Yeah, so let's go to the next slide, I think. So in order for us to meet the problem statement of trying to deal with sort of a common set of requirements from the hyperscalers to the GPU vendors and be able to work together. Standardization is, of course, the best way to do it, and OCP is probably the right organization under which this should be standardized. And that's why it allows the vendors, to deliver products to different hyperscalers, with one set of requirements, while still be able to differentiate. And then it allows the hyperscalers to take products from different vendors with the same set of requirements and the same set of tools, and a common set of software. So that's why we decided that we want to standardize a few things under OCP, and firmware update, of course, is one of them. Next slide, please. So with that as the background, the problem statement, and the goal of standardization, we formed a working group, sort of an OCP private working group, And between NVIDIA, Microsoft, and Google, we signed the CLA late last year, and we identified sort of 3 areas to look at: management interfaces and OpenBMC. So all of them, of course, are manageability focused. We're not focusing on the data path, application stacks. We're really focused on manageability, and so the 3 areas are around manageability. One is the management interfaces and OpenBMC, which we are targeting to live under the hardware management project. Second one is RAS. Bhushan, who's on the call, is leading the RAS working group or work stream, and that's also targeted under the hardware management project. And the third one is firmware update. The content of today's presentation, and we'd like to target and live under the OSF project. So if you look at the pictures on the right, all 3 work streams, essentially this effort looks at the GPU and in 2 different models when defining requirements and interfaces. The top one, which is labeled UBB, or Universal Baseboard, but it's really talking about GPUs as a subsystem, where you have GPU products that have multiple GPUs in them and other components, like they could be interconnects, fabrics, switches, retimers, PCI switches, a bunch of things like that in there, and is expected that it'll be fronted by what we are calling a management controller, which here we're calling it accelerator management controller. And this entire thing will expose sort of a Redfish interface that a BMC can consume, and then eventually the hyperscaler data center services can consume and use. The second model, when we talk about GPUs, is the discrete GPU, your sort of typical PCI add-in card kind of products, which is expected to have an out-of-band interconnect for management, interconnect like I2C or USB, and expected to sort of use MCTP, PLDM-like protocols and transports to manage the GPU. And there's still a BMC in the picture. There's still a hyperscaler, data center services in the picture. So all the work streams sort of use these 2 as the canonical GPU model, if you will, when defining, their work scope. And we'll get into, what we are doing in the firmware update thing with respect to these 2 models in a bit. And the approach, of course, is we want to work on define specifications, sort of a requirement on these various work streams, and also pair it up with compliance tool that can be used by both the vendors as well as the hyperscalers to make sure the products are meeting these specifications. Next slide, please. So before we get into the firmware update specific things, just wanted to quickly touch on why this work we think is in compliance with the OCP tenets. At least 4 of them. I think the sustainability doesn't quite apply in a sense. So with respect to openness, of course, we've got 3 companies, partners and competitors, gathering together and basically openly, sharing ideas and defining these requirements. We plan to, open up the specification under OCP, and then slowly add more partners, so that the ecosystem that defines this, grows. From an efficiency standpoint, we are looking at, essentially the whole problem statement here is to make these GPU products, creation of them, integration of them into hyperscaler solutions efficient and frictionless. And that so all this whole thing is really about efficiency. And the impact, we expect this to have a significant impact. It is really the first industry initiative to standardize GPU requirements. So we are pretty excited about that. We think it'll not only be useful for hyperscalers, it'll be useful for enterprise deployments as well. going forward. And then scale, of course, there's all the hyperscalers together, have very large scale GPU deployments today, will continue to grow in the future. And so the work we do here will apply to a significant scale of products, at least in the world of data centers. With that, I would like to turn it over to Vishal to continue down on the firmware update specific work.
Thanks, Joy. So, sorry. Oh, so there is one more slide left, I guess.
No, this one I think you can take, like what
Sure.
what we're trying to. Yeah.
Okay. So basically, sorry, I was.
Yeah. Should I do this?
Yeah, I was not
Yeah.
prepared for this
Yeah.
one.
Yeah.
So.
No issues. No issues. Yeah. So why are we looking at firmware update? Well, it's we're preaching to the choir here, but firmware, firmware, of course, is the most critical thing to maintain for GPUs, right? For any devices, as we know, to maintain, stability, security, performance, everything is affected by firmware. And whether we like it or not, revisions of firmware happen during the development of the product itself, during the integration of the product into the hyperscaler, and during the lifetime of the product, right? Through however many years it lives in the data center. And so it is one of the most critical operations, a very often done operations, and if done either incorrectly, or if not done in a robust manner, it can break large portions of data center machines. So that's why firmware update was one of the topics we decided to work together to standardize. And what are we standardizing? Well, we are, first of all, the scope is it includes any mutable components in the GPU. So if you remember the UBB, the GPU subsystem, any components there that requires firmware, that's included in the scope. And we are doing two things in the specification. We are defining capabilities for these firmware updates, which are in which Vishal will get into a little more details next, which are required to deploy and operate these GPU systems, at the scale that hyperscalers typically operate. And then we are defining interfaces to support these capabilities. And then if you look at the picture on the right, it's very similar to the model that all the work streams are working towards. And what are we doing there in that model? We are defining the Redfish interface, we are defining the PLDM interfaces, and we are defining the capabilities of what that green box, that is the GPU subsystem, whether it's a single GPU discrete or a subsystem. So that's what we are doing, right? So mentally, capabilities of the green box, what the green box should expose, whether it's discrete in terms of PLDM or Redfish, and what the BMC should also expose with respect to Redfish.
So do you want
Now
to
I'll
take
turn it
questions,
over
or
to, yeah.
now,
So,
or
yeah,
you
go
want
ahead,
to
Sammy.
save until to the end?
No, go ahead with questions, please.
So do we have what is the definition of what are the items included in the GPU boundary? What is GPU? Is it a discrete processor, or is it a collection of processors, or does it have all the root of trust, all these things integrated, or is it not out of scope? Do we have some
good
boundaries
question.
around that?
Yeah, good question. So actually, maybe I'll let Vishal or somebody else answer that. Go ahead.
Sure. Sorry, Sammy, right? Sammy, we are the boundary of GPU is based on products, right? For example, when we talk about discrete GPUs, we are talking about PCI form factor products, which which have GPUs, but security is built in as part of the product. So eRods and other supporting devices, they become the part of product, and they also comply with the requirements that we are putting forth in these requirement specifications, right? So one set of product is a uni GPU PCI card. Then there are UBB designs where you could have 4 or 8 GPUs, right? Now, as the increased number of GPUs, the number of components on that base, number of firmware or updatable components on that UBB, increases. So we are saying that all of those components lie under, the preview of these specifications. So all of those components have the baseboard in particular has to comply with the requirements that we are setting or putting forth in these specifications. So how it does not mean that every component on baseboard natively have to support, say, PLDM as an example, but if we go back here, sorry,
I think my question is different.
okay.
My question is, when we say GPU, are we only saying it's the processor, the GPU processor portion of it, or is it contains collection of it, something like SmartNIC, contains multiple different components underneath?
Yeah, and I think that's what the two models are, Sammy. It is not just the GPU traditionally what you think of as the compute element,
Right.
but anything that makes up the GPU product. So it is and the true definition of product is a discrete GPU like a PCI product,
Right.
and a UBB based product, essentially.
Then it's a collection of functionality in addition to the GPU.
That's correct, Sammy. Like Ponte, you pick an example, right? Or Hopper, right? So where the GPU board has its own like GPU processor and the the HMC, in this case the BMC equivalent, and then also the FPGA, then the EROT. You talked about ROT, right? It has its own security,
Right.
root of trust, one or more. So it's a collection of firmware that we basically kind of bundle and update.
Okay.
But the main functionality is one of GPU. The thing produce the capabilities is what the GPU does, right? Everything else is supporting, right, from that perspective.
Yeah.
Okay. Yeah, I will let us say the whole proposal before I comment. I think I'm trying to get my minds around. Is it just a GPU firmware we are talking about, it, or all the even additional firmware along with the GPU? Right?
Good.
All of it.
Vishal will talk about that a bit. Yes, but yeah, short answer is what Karu said.
Okay.
It's all mutable components within the boundary of that GPU product.
Oh, good. Okay.
Cool. So let me see. Okay. So I think I flipped the slide around. So before we went and started articulating the requirements, we tried to understand why hyperscaler use case is different than why hyperscalers do things differently, right? So we started out with, if you look at on the left side, what are the orchestrator states and what are the GPU usage models, right? And what are the MVPs that hyperscaler care about? So what it turned out to be is hyperscalers don't want to disrupt GPUs which are in service they want to prevent any downtime on GPUs, right? So they also want flexibility to break down firmware update into discrete steps, which we'll get into details, right? And they also want all the firmware update mechanisms to be secure in nature, right? So with that, we found out that we can break down firmware update into 3 steps, right? Copy part, which is actually taking the payload, firmware payload, and transferring it over to the EEPROM of the device of GPUs here, which it is booting off of. Arming Arming meaning, now you have copied over the image, but you can defer booting off from that image. That is what we are calling arming. So, let's say GPU is in use, you have a workload which runs, say, 1 month at a stretch without disruption. So we could prep up GPUs with firmware update without arming it, right? And then finally the activation step over here, which causes the a downtime, right? Because of the reset penalty that a device or a GPU has to take. So with these with this use case and orchestration states in mind, then we went ahead and said, okay, what are the requirements that a vendor has to come? Yes,
before going the previous slide, you're copying it.
Yeah.
And when you're saying arming, are you saying like you have multiple GPUs inside, and out of let us say 4 GPUs, you may arm only 3, then you can activate 3, or?
Yes.
Okay.
You can activate individual GPU, you can activate all GPUs, you can activate a tertiary component without activating GPU firmware, like root of trust in this case.
Okay. So you can select within the system a subset of it, I want to activate it.
Yes. So yeah, every component on the baseboard, if you're talking about a baseboard, complies with these steps and states.
Okay.
Right. So now with those use cases in mind, then we started going down requirements in primarily 4 areas, right? What should secure firmware update downgrade requirements, right? What should be the update time, right? We, prior to this collaboration between Google, Microsoft, and NVIDIA, there was no goal for us to aim at, right? Then we came up with a number on update time which is acceptable to hyperscalers because they could afford that downtime, and their orchestration firmware could abide by, right? Then what are the image signing requirements? What are the algorithms that that a signing infrastructure should support to facilitate secure firmware update? What does non-disruption mean, right? Prior to this collaboration, we would, hyperscalers would say it should be non-disruptive, but like we see over here, now we can say disruption is only in the activation state, right? You are not vulnerable to failures if the copy operation fails or a ARM operation fails, right? The disruption is only if during activation, right? So, and that's a narrow time quantum, as opposed to taking the whole system down for firmware update and then returning it back, right? Then we also vetted out image formats, right? Image sizes are, because since we are plugging in into host BMC, that hyperscalers build. We want to know if is there an image size limitation that we have to conform it? What if now we have multiple images in UBB design, right? Should we be packaging all of them together so that we prevent, issues like firmware version A is not compatible with firmware version B. So we ship pre-tested compatible firmware images in one PLDM packaging, structure, right? Then we went down the path of defining the resiliency and redundancy behavior of firmware update. So, what happens if somebody knocks off the power supply while firmware update is happening? What happens if you get asynchronous reset of the device when the firmware update is in process, right? What happens if Redfish client, which is initiating the firmware update, itself dies? What happens if the firmware update, the code which is performing the firmware update itself dies after writing half of the flash, right? So we have articulated all those resiliency and redundancy requirements in the specification. And finally, the telemetry for firmware, right? How many images are there? What are the version numbers of these images? Which image the GPU is booted off of, right? What are the signatures, or what you call SHA measurements of these images and things like that. So we took a holistic approach from use case at a cluster level use case all the way down to the silicon or silicon failure modes or an orchestrator failure modes, and define the requirements so that hyperscalers can pre-bake the workflows with Redfish APIs that are also called out in the specifications. And so when a new product that NVIDIA or any other GPU vendor publishes or produces, they can just be integrated readily, right? Because GPUs will conform to the same standards that hyperscaler orchestrator has codified their workflows with. So with that, I think I'm going to pass it on to Karu to explain, give a flavor of Redfish APIs that we are defining here.
Great. Thank you, Vishal. Before I proceed, Neil, Sammy, and others, you have any questions to Vishal?
I think this is a very okay. This is a very good, really good topic. Another one is actually we also I mean some issue. Also have some proposal on the GPU or PCI card. It's about the auto band command because such as so GPU from NVIDIA or Mellux network card. So some auto band command are different. So we have a proposal. Maybe we can also can define some auto band information combined together with this topic. Yeah.
Sure. Okay. Yeah. So yeah, they again, like when we come mainstream to OCP, I think that is where we can solicit more feedback and harden the spec even more. Definitely.
Absolutely. All right. So, for the use cases that Vishal talked about, right, in order to support those, there are some, gaps in the existing Redfish firmware update APIs, right? So that's why, our, the new spec that we're publishing is going to introduce, a few Redfish API enhancements, right, to perform the, the staged operation. The first one is basically, staging the firmware bundle of your choice or hyperscaler choice onto the the staging area. It could be an eMMC, which is part of your AMC. It could, when you call this, it could basically stage the bundle onto that eMMC, and as part of this API, it basically returns a handle, to kind of let you know hey, here is the location with the response code 201. It basically gives you the URI of the created resource, which targets to the staged area, right? So once you have that resource, you can see that in the in the second main bullet in the arming area, you see that the last line, red page, blah blah blah, with the 0 in the end. That is a location you get along with the stage firmware, pack URI. Those are the two information you get as part of the location, right? You got to use those to arm the firmware, right? So once you stage the the bundle will be returned onto the the persistent area. It could be eMMC. In case of if you have multiple SPI, it could be SPI as well. And then on the arming is basically the operation of real writing from the eMMC to the your firmware storage, real firmware storage, right? So this is where we have introduced the new API. You can see that the target, it is basically kind of pointing to the persisted storage area where you basically persisted. The goodness here is that Sammy was asking, hey, can we do a single firmware update, or you could do a bundle update? You could do both using this ARM API, right? There are targets you could specify. We have not called out here. you could, using the target kind of attributes, you could specify the your own target. If you just want to update the GPU only, you could do that. If you want to update the bundle, you don't have to specify the target. By default, the whole bundle gets updated, right? That's the beauty of the ARM API. The third one is basically, hey, kind of, your orchestrator want to check, if the either a firmware bundle is really staged or not. You can call that, and then as part of this API response, right, which again use the same handle or the URI that was returned by the first API call, right? You use that and then call the hey, get me the status of the staging. It basically returns, the return, includes something like the verification status, whether it's success or fail. It could also tell you the firmware update, package version that you kind of stage. It could also return the hash thing that Vishal talked about, right, at the time at which you stage. It could return all those data to you, right? And then usual the Redfish task API, the last two APIs you could, is kind of nothing new. You can use those or to, monitor the progress of the, the arming operation, and then kind of, see if it is, complete or not. That's the usual Redfish task monitoring, right? Once the task is fully completed, you could follow your activation method of your own choice to activate the state firmware, that got armed, right? So that is the workflow that we envision, right? These are some critical APIs we wanted to call. There could be more, but for now, these are the critical ones.
Yeah, quick question. Why are we putting OEM OCP instead of standardizing in Redfish?
Yes, that's a good one. For now, I think as current implementation on one of our project is like that. We will be willing to change that to standardize it to OCP
Yeah,
requirement.
I think in a CSM, we were doing telemetry work with OEM OCP.
Mhm.
Publishing the white paper got blocked because they want to get that end goal done, working with the DMTF to complete the work rather than putting a intermediate thing and asking people to implement this and later change it.
Good one, Sammy. Yeah, we will comprehend that one, that input.
Yeah, I think this is as you know, it's a combination of some expediency. So idea is, of course, many of these will have to graduate to DMTF standards. But Sammy, what was blocked? I didn't follow.
No, they don't want to allow putting OEM, publishing it and saying people can go and implement, and we will be changing it in the future for Redfish. So they basically said to work with the DMTF, complete the Redfish definition, remove the OEM OCP they recommended.
Who's they? Yeah, sorry.
It's basically from the OCP forum, right? ICs.
For the incubation committee.
Yeah. So I would, if you are considering it could be standardized through DMTF, it'll be good if it's standardized so that you don't need to do a temporary implementation and change the implementation again, right?
Can
It's
they
okay
happen,
for prototype.
Sammy?
Yeah.
Like standardizing, we review with OCP as of the spec, along with we kind of we can later standardize the Redfish API through DMTF, or
They're asking to file in the DMTF before publishing it out. Use
okay.
that DMTF. You can put a work in progress.
Okay.
You can publish it. Then point to the whip here with the right the thing. Remove the OCP.
Okay. Thank
So
you.
do a whip, do a
You submit to the DMTF.
DMTF as a whip.
Yes.
Okay.
Then you can point to that whip and then you can publish it. Remove the OCP.
But so we publish it in as a we capture whatever we proposed
Yeah,
in the
whip
whip.
version
right?
number, whip date is there, right? Then if it gets updated, then you get reflected the update back.
Okay. Thanks. This is
Yeah,
great
good
feedback.
Yeah.
Yeah.
Yep. Can we move on, Michelle, to the next slide?
And one more quick question. I think another question I had on the first one. I thought downloading firmware already in the Redfish, right? What is it? Something is it missing in the current update services?
Yeah, so the current one, basically, if you really look at Sammy, the firmware update API binds the staging of the firmware bundle to the AMC and the firmware update aspect onto the device as one operation. It doesn't let you the split operation. Okay, I want to basically kind of stage, and then I want to kind of do the update later, right? Like when the hyperscaler decides, right? Like okay, hey, I want to, kind of, state the firmware package in the AMC while the system is in operation. I want to activate it basically during my maintenance window. If all of a sudden, if some, restart happens, I don't even want to activate that new firmware which got updated, right? So it doesn't, address this kind of concern, right? So
My
that's where,
thought,
yeah.
my thought is for PMM firmware, they had a separation of download on activate defined.
For which one, Sammy? Oh, for your
For-
persistent memory?
For
Yeah.
Redfish though, in Redfish though, Sammy, do you remember if it was in Redfish? You're saying?
I know it is in-band defined. I know there was a attempt made to make it as a Redfish, but I have not followed fully whether it is all got done or not. John probably know.
You have to check with Mr. Leong. Huh?
Yeah.
Yeah, so we can look into that, or maybe we can ask John. But we didn't. So the firmware update that exists today, like the update service, like Karu said, is really what Vishal's showing. It's the copy arm sort of step together, and we will maintain it for backward
It was
compatibility.
calling downloaded rather than copy, but it's a
Right.
activate. Yeah.
We will find it though if it exists. I don't think we found it. And so what we are proposing here is to enhance the update service
Right.
to add these two. But if somebody wants to still wants to do this one shot, they can continue using the existing firmware update.
Right.
But we'll look into. So think John would be a person to ask.
Yeah, John Liang. Probably.
Okay. All right.
Thank you, Sammy.
This is cool stuff. We may not have to go OEM OCP route then.
That would be great.
It's already available.
Yeah. We'll send a chocolate box to
I
Sammy.
think the OCP there is still OCP contribution required because if you want to say a platform supporting GPUs need to support this functionality because in Redfish or DMTM they might say these are optional functions.
Right.
Possible to implement. If you implement, you have to follow these mechanics.
Fair enough. Yeah, good
But
one.
in OCP profile, you will say you must carry if you want to certify with whatever the GPU thing, right?
Got it. So in our spec, we would say here are from an OCP spec point of view, here are the required properties and interfaces from the big Redfish schema. Yeah, that we would do, yes. But at least if the thing exists, then we can avoid this OCP OEM. OEM
because
OCP
if you put onto OCP, OEM OCP, then you're allowing multiple different implementation, then you're not going to get a standardization still, right?
Right. Yeah.
Yeah, that's why we kind of color coded it just to get this input. Yeah. Good one, Sammy. Vishal, next one. Yeah, for the discrete, the Redfish API implementation will have to be supported by the BMC, right? Or the GPU is expected to support the PLDM type 2. BMC can implement the Redfish API similar to the model that we showed. I mean, the existing, Redfish APIs could also be implemented on top of the new ones, right? If a BMC wants to kind of, stage, it can. Again, it's all, the implementation specific. And then the BMC is going to basically deal with the GPU current firmware update to the PLDM APIs, right? So that is something, the spec will also talk about, right?
But you are differentiating differing PLDM for a discrete versus non-discrete.
Vishal, you want to take that?
Yeah, so we think, PLDM type 2 acts as a primitive, right? And when we go to non-discrete product, there might be, so from, let's say, the GPU vendor perspective, we do not control, say, retimer firmware update capability or a PCI switch firmware update capability. But by conforming to these APIs, AMC can offer this firmware update steps and status view to host BMC or to an orchestrator, right? That's where we are saying, for a discrete GPU product, GPU should support PLDM type 2, which means then we can put Redfish wrappers around PLDM state machine and orchestrate the same way to get copy, arm, and activate behavior.
Yeah, from a hyperscaler view, if a GPU product has a management controller like the UBB based products, we want it exposing Redfish. What it does internally from an hyperscaler requirement standpoint, it doesn't matter. But we want to talk Redfish if we can to that kind of set of that sort of product, and not PLDM. But for discrete GPUs, it doesn't have those management controllers. So we recognize that and we say, okay, that's good to do PLDM because we'll have a BMC that'll take care of the Redfish, Redfishizing, if you will.
So you have a discovery mechanism. You can identify supporting PLDM or Redfish, and then based on that, the actual final BMC or super BMC can make a decision.
Correct.
That's a good question. I think the way
Yes. Yeah. That was one of the plan,
yeah.
right? Yeah.
So
Yeah, I have a hard stop at 9.
Yeah. So I think we can.
Neil, sorry. Yeah. Go ahead.
Karu, if you want, I can take this.
Yeah.
In
Take
case
that,
we
please.
go
Yeah.
over. So just on next steps and where we are. Like I said, we've been working on defining some of these things that Vishal and Karu talked about, and we've put it in a document that we're calling 0.7 just because it's not 1.0 because we want to get all this feedback and like even what Neil was talking about towards a 0.9 and 1.0, but it's got, I think, enough material that sets the direction of what we're trying to define and addresses the basic problem that we're trying to solve. So we'd like to publish it in next month. So next week, we go to the IC to get approval. FSAs are in process of being signed by the 3 companies for this version of the spec. And the idea is then we'd follow it up targeting the OCP Global Summit. You should see an abstract. I don't know, Sammy and Niels, if you guys are the ones. I mean, this thing is going to go review the abstracts, but we have submitted a presentation abstract under the OSF track for this topic, and we'd like to do a 0.9 version of the spec by then. And between now and then open up the discussion to more partners, and not just limited possibly to just 3. And then we still have a bunch of topics to close 0.7. Apart from incorporating feedback, already we got a ton of good ones today. But we still have some topics to close. Our debug telemetry and some more telemetry, richer telemetry we still have to define. We have some capabilities, right? When redundant copies should resilver and sync, we have to define that behavior. If partially, if the update fails, when there's multiple components like we talked about that need to be updated and only 3 of them actually got updated, what should be the behavior? We want to define it very clearly. And then the Redfish spec, Karu went through some of the key ones like that we need in the change in the interface, but there's a few others as well that we know of. They're not super, I mean, they're all important, but they need they need to be there to match the requirements. So we have to add some of that as well. So we do have some work to be done after 0.7, in addition to getting incorporating feedback. So that's all we had today. Well, first of all, thank you for the opportunity, and thanks for great feedback. We'll process that feedback. And
thank you. Have you submitted the global summit?
Yes, we have submitted
Okay.
an abstract for this. Yes, under
Hey,
the
Sammy,
OCP track. So hopefully you've seen it.
Sammy online?
Yeah.
Yeah. Maybe we can check how we could help to for the release in the OCP, the processor.
Yeah, we will go through the process, right? There's a FTN review is Friday. Then after that, it will be open up for the submission to be reviewed, right? We'll go through the normal process.
Yeah, before they need to review the proposal need kind of the spec proposal need to review in the IC meeting, I think, before. So
yeah,
so maybe we can check.
Once
Yeah, we can check offline.
No, Friday, my understanding is it's a training for how do you review the paper submissions and vote it, not a final voting there, right? It's training for how do you review the papers and materials. And I think Neil will let us close offline on how we want to handle it. Just for the feedback, right? I think, thank you. It's a good presentation here. I think another thing is, I think as a OCP, we want to define the runtime firmware update requirement, not only the GPU or add-on card or at a system level, right? I think there are cases that we should collaborate and make sure that overall runtime requirement is comprehended in a definition. I think we need to work together to put together that next step also.
Okay. Yeah.
Sorry, what do you mean by runtime requirement?
So it's a system level firmware, right? It's a system firmware or add-on firmware. Add-on can be GPU or can be CXL, can be SSD or a SmartNIC, anything, right? We took an eye last year to define a requirement for a runtime firmware update. There are some of the portions that you are highlighting here. There is a requirement for GPU side. We also need to apply to a system level side. What is the requirement?
Right. Okay.
We should bring it back for a review. I think Vishal and I don't remember. There's another person signed up to work with the team to define the requirement. I think we should. You already have some of the requirements defined. I think we should combine all the requirement one big requirement and make it a system level.
I see. Okay.
Yeah, essentially make it a little more generic for
right.
system level cards. Yeah.
Okay.
Yeah. So once we at least get this spec out, we can all see what it says, and then we can say, okay, what else needs to be added to make it a more generic runtime system thing. I think, Sammy,
yeah,
right?
I think there's two things, right? One is if you want to, like, that's why I was asking the definition. Is a GPU is just a processor? Are you really saying a system? Right? If it is system, basically meaning you can have CPU or GPU. It doesn't matter. It's all compute engines, right? It can be smart. Right?
It is a subsystem. No, you're right. I mean, most of these are very common. I think the issue, most of them are applicable to others, but I think maybe protocol wise, an SSD may have
different class. Yeah, but
totally different class.
Right.
Even SmartNICs might have some. There'll be some quirks that, I mean, GPU has some quirks, but many of them, the way we will package, the way we upgrade and downgrade securely, I think those things are all applicable.
Right. That means just say system doesn't matter whether GPU or CPU or FPGA or anything else sitting in the system, right?
Yeah.
So I think we need to see the content before really like say how much you're limiting or you're making it open, right?
Sure. Okay, sounds good.
Thank you.
All right, so we'll upload the spec for, I guess, for OCP member view things next week before the IC.
Okay.
But it's pretty much this what we talked about.
Sure.
Yeah. All right. Anything else, Sammy and Neil?
No, do you have a spec or the presentation files link? Could you share with me? I
Yeah,
can put in the.
we will share it next week, Neil. We didn't realize OCP has a specific format, so we have to change our document to the OCP format. And so our IC incubation committee meeting is next week, 6th. So we'll send the link out before that.
Okay, thank you.
So you're not really seeking any approval or anything from here, right? You're saying like you're notifying that it's happening, right?
I guess we're notifying, and when we present to the incubation committee, obviously it's going to be a just very high level for all the work streams. I'm assuming they will check whether we've talked with you guys and you don't have major objections. I suspect, right? I don't know how the process works.
I don't know. We need to check with the IC side. I never gone through that fully.
Okay. So anyway, if somebody, maybe it's Dongwei, I don't know.
Okay.
He's the rep, right? So maybe, unfortunately, he's not here today. But I don't know, Sammy, if you or Niels want to just give Dongwei a heads up.
Yeah, we were talking with Dongwei. Dongwei
Yeah.
right now he's in the travel. He's in the travel in the PRC.
Okay. All right. Yeah. So if you can give him a heads up, that'd be great. That at least
Sure.
we talk to you guys, and at least there's no major objection, right? You have to see the spec and stuff, of course. Is that okay, Sammy? And
Yeah. Possible you can share send the files link to me. Yeah, I can send. Yeah, I will share with the Dongwei and some other people. Yeah.
Yeah, we'll share this presentation. Yeah, I'll share.
Yeah, I think the main concern is like I pointed, right? OCP that OCP private. I think the IC wants to see if it is going to be Redfest general standardized. They want to make it as a present it to DMTF and make a whip. Then put a whip pointer, that way people, if somebody is implementing it, they're implementing with a DMTF whip so that they know it's not, they don't need to change the implementations later. That is one of the concerns they brought up, and when we are submitting a CSM, they blocked it. So we are going through the DMTF process now.
Okay.
So I hope this is not a experimental. It's you are expecting this to live long, right?
Yes, absolutely.
So if that is the case, I think we should follow the process and make sure that I mean, they will give you similar feedback. So if you, I don't know, I am not IC, so you can go through that, but that's what they're given feedback. So maybe you should prepare for it.
Okay. Yeah, we'll see. I guess meantime we'll check with John in case maybe it already exists. Okay. Then that problem will be solved, and if not, I guess we'll have the conversation in the IC.
Sure.
But I think from this project, I think we're hoping that apart from the feedback you gave, the overall thing you feel that it can fit under OSF. If we go ahead and publish, and then
it's a kind of a OSF charter, right? It's a system contains many kind of firmware, right? We need to come deal with it, right? I think one of the things we really want to talk about, it's not just the BIOS, right? It's the whole system firmware, all the things, components goes along with it, right?
Yeah.
So
Correct.
it's part of the charter, but we want to make sure that all the components, right? We have a what we are defining. It's really not just pointing to one particular problem, solving one particular problem, right? You want to make sure that it's comprehensive enough.
Yeah.
Right. It's a high level. You're given an overview, but we need to look at the spec to really say how much it's covering, right?
Yeah. Okay. Sounds good. All right. Thank you. Thank you everyone for your time.
Thank you. Yeah.
Yep. Thanks everyone.